So, good morning, everybody.
Good morning.
Okay, good morning, Dr. Mages.
Yeah, good morning, Dr. Norma.
Yeah, okay, nice to see you again
Yes.
in the middle of the week.
Yeah, can you hear me?
Yes, clearly.
Okay.
Yeah. Okay, we have already 5 students here. Hopefully, the other student will join soon. And for the student, don't forget to check in your open courseware to check yourself in the attendance list, both in problematic chemistry learning as well as in material course management. Yeah. Oke, mohon diingatkan teman-teman yang lain ya. Yeah. So we can start on time. Now in Malaysia is start rainy season also, Dr. Mages?
This is our second week. Second week of the semester. So we started on the 25th.
Oh, and how about the season? Because in Indonesia with the heavy rain is start last week.
Oh, okay. Now it's like that the weather is actually extreme. Either it goes very heavy rain and then it becomes very hot. So it's like, one day it will be extremely heavy rain, raining heavily. And then another day you will see it's so hot. It will be really hot until you have, I will try my best not to use air conditioning. But then it will be so hot until you still have to on the air conditioning. Sometimes the temperature can reach up to 36.
Yeah, that's right. When the rain is not coming, the weather becomes so hot.
Yeah.
And then in the afternoon, sometimes the heavy rain come, right?
Yeah.
It's the same with us.
It's like you can't predict. Those days we have something, we call it as hujan perolakan. That means we have this. That means every afternoon we will get rain. Then after that we will get sunshine. Those days that was the scenario. But nowadays it's not like that. It rains like crazy. Until it gets flooded all over the places. And then the next day will be hot, so crazily the temperature become very high, even immediately after the next day. So it's now unpredictable, and it's like people saying climate change. So this is one of the impact of climate change, I suppose.
Yes.
The extreme weather and so on, and also how to what extent people are really concerned about protecting maintaining the cleanliness and all that. You see, the rivers, they just simply throw rubbish in the river, and when it rains, that's it, flooding everywhere. That's one main reason why it happens in that way.
Yeah, that's correct. Yeah. Okay. Now most student is already in this room. I would like to say hello to Mas Umam. Is already there? Mbak Rahma, Mas Gama, Mas Haji, Mbak Reti, Mbak Maria, dan juga Mbak Dwi. Silahkan bisa ya. Oke. Mas Haji, Mbak Reti. Yeah. Okay. Now we have already in the third meeting with Dr. Mages Warikarpudewan. Last week, I have already shared what materials, topics that we will discuss today regarding conceptual change theory from Posner. Hopefully, you have already learned before this meeting, so we can discuss with more motivating, because you have already read about that. Okay, Dr. Mages, now time's to you to continue our discussion. Now come to conceptual change theory. Time is yours, Dr. Mages.
Okay, thank you, Dr. Norma. Okay, thank you for staying with me. So this is our meeting. So you are being patient and listening to what I'm saying. So hopefully all my sharing will benefit you. You will take up all this information and then use it either in your theory or writing papers or whatever. Okay.
Yeah.
Right. So last week I stopped at the conceptual change model, correct? But I didn't really go deeper into it. So today I will tap on the conceptual change model. And also, I will show you some examples that my students have used, and also you can actually read. If you Google my name, you will get some publication which I have reported on Misconception. If you are unable to get the full paper, you can just email me or what. You just can tell me I'm from Dr. Norma's group. I will share the publication, because sometimes I get many emails, and some of it I don't respond because it's just simply too many, So if you say I'm from Dr. Norma's group, I will take the initiative to really respond. Okay, right. So then I'll show you some example of how we have used this model in designing instruction that overcomes misconception. Okay, right. So let me share the PowerPoint first. Actually, the last week's PowerPoint. And from there, I will focus on the conceptual change model. Okay. Oh, okay. Having problem sharing. Hold on. Okay. So you can see CCM in my slide. Right. So CCM or conceptual change model. Actually, this is Posner's model. Posner actually come up with the model. So I have actually shared the article, Posner's article with you, and you might also go and read about other work that Posner have actually employed this framework, this model, and then they explain how when teaching is constructed or teaching is designed using the 4 frameworks of conceptual change described by Posner, that can result in reducing misconception. So Posner also actually, he didn't come up by himself, but he actually referred to John Piaget's work. His work, Posner closely referred to John Piaget's work. So knowledge construction, how knowledge construction happens. So just to give you a brief description about how knowledge construction happens. You see, in our mind or in our brain, when you teach something, or when the students when we say the students are having some kind of understanding, so, or when we say when the students are having some knowledge about certain concept, so what is the meaning of students having knowledge? The meaning is that in their mindset, in their brain, they have networks. We have many networks. So each networks represents some kind of information, networks of information. So when you say photosynthesis, so in the student's mind, they will have networks of information about photosynthesis. So there will be many networks. So the students, when the moment you mention photosynthesis, so they will try to, the networks of knowledge will the student will try to rationalize, without them knowing, in their brain, they will try to rationalize. The meaning rationalize is, the meaning of rationalize is they will try to connect the networks, as I said, the knowledge, the information is stored in the brain as the form of network. Okay, so when we say photosynthesis, or when we say rate of reaction, or when we say kinetic particle theory, the moment we mention that, the student will, the existing network, there are networks already existing. So what they will do is, the networks, they will try to rationalize, they will try to make sense. So when they try, in the process of making sense, they will connect all the networks. So the connecting the networks and making sense of the information is called knowledge construction. Knowledge is constructed from the students trying to rationalize the information, whereby the information is stored in the form of networks. That's why we have long-term memory, short-term memory. We talk about working memory capacity. I'm not sure whether you have heard about working memory. So every one of us, we have this working memory, and our working memory, there is a kind of capacity. Some people can have a higher capacity, and some people will have a lower capacity. People with the higher capacity would have the ability to process the information faster or more information. Students with the lower capacity, might not be able, they don't have the ability to process large information, or they might not be able to process the information in the given time. So what is the meaning of processing information is rationalizing the networks of knowledge. Later I will show you some examples. Rationalizing. So we have many networks, we are trying to make sense of the network, and the student will come, and at the end they come to a conclusion. Oh, this is the meaning of photosynthesis, this is the meaning of rate of reaction. So what change happens when they're in the process of making sense, they realize that, oh, the knowledge that they having is not accurate, or the knowledge that they are having is partially correct, or they need to do something to make sure that the existing knowledge, to bring the existing knowledge to the knowledge accepted by the scientific community. So what happens again in the processing, during the processing of the information, the networks, they are trying to connect the networks of knowledge, they will experience some kind of changes. So they will say, okay, maybe in me connecting the first two networks is not appropriate. Probably I need to do some changes to the existing network, and then I try to make sense of the new knowledge that comes in. So Piaget calls this as accommodating. So accommodating to the existing mental structure. Okay, so when conceptual change happens, when the students try to shift from the incorrect or partially correct conception to the new or fully or correct conception. Okay, that is called conceptual change. Conceptual change. So when during the conceptual change, what happens? The networks of knowledge it functions in a way that they realize the existing conception is incorrect, and the new conception that the teacher is telling is the correct one. So they're trying to accommodate and to the new concept. So Posner said it won't work just like simply you teach. Okay, if you just do an ordinary teaching, it won't be so effective for the conceptual change to take place. That is the Posner's finding of his research. Earlier people like Piaget and all that, they said, okay, knowledge is network of knowledge is rationalized, it is connected, it is compromised, it is makes sense to come up with the new knowledge. But then Posner said, these things simply won't happen unless your teaching is designed in such a way that for the students to experience conceptual change. So in order, how then the question comes up, how can we design the teaching in order for conceptual change to take place? So Posner proposed 4 stages. In your teaching, you must make sure that the students can experience the 4 stages. When the students experience these 4 stages, then conceptual change can take place. Okay, so conceptual change, again, I would like to stress here the connecting of the network of knowledge. So maybe at one point the student will find the connection is not making sense. So they will try to accommodate the new knowledge that the teacher teaches. So the new knowledge, in order to effectively take place in students' knowledge construction, the first stage, the students must have this experience, or they must have the feeling that the knowledge that they have is not fully satisfactory. So they find that there is some lacking. You know, they find that there's something is not appropriate with the current knowledge. You know, so for them to have that feeling, you know, for them to have that feeling, the new concept must be intelligible, understandable. So if the new concept is also a kind of this creating dissatisfaction, you won't the new knowledge would not create conceptual change. So the new conception that you are trying to teach, it must be intelligible or understandable. And then the new idea must be something the students can trust. Oh, I understand, I believe, plausible, I believe. Okay, this thing will work. Then the new knowledge must be fruitful when they should be able to apply in the real life. The moment they apply in whatever problem they're given to them, they see results. They see results. So the moment they can see results, oh, they say, okay, the knowledge is fruitful. So if these 4 phases of Posner is reflected in the teaching, then only conceptual change can take place. If not, the students will construct knowledge, but then the knowledge might not be fully correct. I wouldn't say it is totally wrong, but it won't be fully correct. You know, totally correct understanding. Okay, now I want to talk about what is dissatisfaction. You need to understand what is dissatisfaction. Ketidakpuasan, you know. So the student, how can you experience dissatisfaction? Bila agaknya kamu boleh rasa knowledge yang kamu ada itu, kamu rasa tidak puas. Keadaan macam mana kamu boleh rasa knowledge itu, kamu rasa tidak puas? That means you realize that something is wrong with my understanding. You know, something is wrong with whatever I perceive. All the while I thought photosynthesis is a process where plants make food. It's a process where plant makes food. All the while I assume that, but it seems it's incorrect. It is correct, but it is partially correct. I'm having a kind of misconception. So the students must experience that. The students must realize that this is incorrect. So the new conception is unlikely to displace the old one unless there is anomaly. Anomaly means something which is not right. So fail to accommodate new experiences into existing networks of consumption. So as I said, there is a network of consumption. So when the teacher teach new concept, the student fail to accommodate the new concept into the existing one. So that means there is a kind of anomaly, ketidakseragaman ataupun ketidaksamaan. So the new concept and the existing concept tidak seragam, tidak selari, tidak sama. Unless the students can have that feeling, then only they can. That means the feeling of dissatisfaction is already there. So unable to make sense of new information. So this satisfaction happens when the students unable to make sense of new conception. They will encounter several alternatives. So the teacher is teaching something. They're having something else in the mind. In the process of accommodating the information, they will encounter several alternatives. So mereka akan rasa, ini boleh ke? Itu boleh ke? Kemungkinan ini ke? There will be several alternatives. So they will try to make conclusion, or maybe this one, or maybe that one, or maybe probably something else. In order to accommodate what teachers say. So this is called dissatisfaction. So you need to design your teaching in such a way that the first step, dissatisfaction happens. Okay, so dissatisfaction is the new conception is unlikely to displace the old one. So unless there is an anomaly, so you need to create a situation di mana the students experience ketidakseragaman. Anomaly is something not parallel with what the teacher and what the teacher saying and what the students having in my mind. So you need to create such a situation. So when that kind of situation happens, fail to accommodate. Then the knowledge is not accommodating. The networks are not coming together. So unable to, when the networks are not coming together, the students are unable to make sense of new information. So it is our nature, human nature. You will try many ways to try to accommodate to something. Correct or not? Maybe this is one, maybe that one. I'm trying to make sense. I have many alternative paths to look into. I'm trying to make sense. So they are trying to make sense, trying to come to conclusion. So this is called dissatisfaction. So in your teaching, the first step is you need to create dissatisfaction. So I hope you understand what is the meaning of dissatisfaction. Second thing is intelligible or understandable. So now you know already, oh, okay, so now I already created dissatisfaction among the students. So now the students are experiencing, they are trying to make sense. There are many alternative thinking that I have actually imposed in them, and I'm trying to say, oh, your understanding is wrong, but I am giving you something new. But in the process of making sense, their students are alternating many things. Okay, right. So among the many alternative paths that you are creating, there will be one path that you have to give them clearly. You have to say it very clearly. You have to present it in very clear manner so that that path is understandable. It is intangible. So that one particular path that you are showing, it makes the students to rationalize. Oh, okay, what the teacher is saying, it makes sense. I think I can accommodate what I have with the new knowledge. So they are making understanding. So the approach that you are using as a teacher to deliver the concept, it allows students to accommodate. It allows students to understand. Yeah, there are many paths, many alternative views that I'm trying to make sense. But the one teacher is saying looks like I can directly relate. So I try to accommodate because I can understand that part. It is that intelligible. Okay, I hope you understand that. So the students will try. The teacher will keep keep on teaching using the method. So when you try to emphasize the concept using the method that you're using, so the students are trying to make, oh yes, I understand. At the same time, it is in line with my past belief. Is in line with my past experience. Yes, when I was doing something in previously, actually I did encounter something like that, because then it matches with my experience with the real world. So I think it also capable of solving problem. So you keep teaching, but the moment you continue teaching, the students tend to relate with their past experiences. That's called plausibility, believable. The next one is fruitfulness. So fruitfulness is actually very simple. You just give them any situation. You can ask them to discover new things based on the new knowledge that you are giving, or you providing more insight. So you can ask them to discover new solution or new solve problem. So the moment they able to solve problem, they will realize that there is no more anomalies. Semua dah jadi seragam. Because what they have, when they use the new conception, when they use to solve the problem is solved. They manage to discover new product or something like that. So the previous knowledge and then the new knowledge is already come to the same line, the same path, same level. So that's why sudah jadi seragam. So there's no more ketidakseragaman. Semua sudah jadi sama. So that is 4 stages of Posner's work. Okay, so I can share you some examples, a few examples how we have implement these 4 stages Posner's work in overcoming misconception. So I would like to share with you the most current work that we are doing. Actually, we have developed this something called Augmented Reality stream work. Okay, STEM is science, technology, engineering, mathematics, right? But we want to expand STEM into stream. Stream is like something like this. So science, we remain the science, technology, we remain the technology. Art here is actually, there are many ways of interpreting art. Some study, they interpret it as religion, something got to do with religion. But in our context, we are not referring to religion, but we are referring to reading and writing. Reading and writing, and E is engineering, A is arts. But then in this A, we are going beyond the arts. Like if you see STEAM education, the A is arts, right? Yeah. But here we are referring to wider perspective. It's also involves arts, and it also involves modeling, multi-modeling. Like in chemistry, multi-modeling, multiple representation is the key to teach and learn chemistry and science. So we are referring the A to multi-modeling and multiple representation. M is maths. So we thought of using this perspective, and we come up with we merge this with the augmented reality, AR. Yeah. Okay, so I'm going to show you a video. So this actually, we have developed this video and we have checked whether this thing worked to overcome misconception on climate change. So I have few projects. One is on climate change, another one is on chemistry concept, pre-university level chemistry concept, and another one is a lower secondary school nutrition. So the one I'm going to show you is augmented reality, whereby we are already completing, almost completion. The other projects are about 60% done. So I am not able to share. So let me share with you. So I'm going to play the video. Just watch the video.
Yes.
I hope I can play the video to you. Okay. Oh no, I need to share the screen.
Mm-hmm.
Hold on. So I have to
stop first.
Stop first, yeah.
Yeah.
Okay. Can you see content lesson 1, lesson 2?
Mm-hmm. Yes.
Okay. Okay. So you watch the video first, then I will explain to you.
So the audio is also included, Dr. Mankes?
Yes, yes. Now I'm going to on now that whether you can listen or not.
Yeah. Okay, it works. Yeah.
Oops. You got it wrong. Try again. That's correct. Good job. Energy budget is the waste and how much energy is used and transferred on Earth by being absorbed, reflected, or radiated. Sunlight comes in a range of short wavelength called visible light. Clouds, atmosphere, and the Earth's surface, which are the lands of the oceans, Okay. So I hope you got what. Can you hear me now?
Yeah.
Okay. Okay. So let me go back to the from the beginning. I'm not going to play the video now, but I hope you have watched the video. So let's okay.
You will be back to the video or PowerPoint, Dr. Mages?
No. I want to go back to the video. I want to explain to you.
All right. Yeah.
Okay.
Ada tuh yang sedang mengerjakan AR juga di S2 tuh siapa ya? Mas, tesisnya yang AR juga. Yang di S2 ada?
Saya, Bu.
Oh, Mas Gama. Mas Gama sama siapa? Mas Gama aja?
Sama Mbak Dwi.
Ya, boleh diskusi nanti sama Dr. Mages.
Okay, so now, so this lesson we are going to talk about. There are many lessons in this AR, but I just focus on one specific lesson and few activities. So this lesson is based on Stream ARCC using mobile phone. So students use mobile phone and it is using augmented reality. So that means augmented reality basically is a 3D dimension. So the student will use the phone and then at the same time they will play around knowing the things and all that. So this is independent learning. The student can learn themselves actually without the teacher's assistance also. It is designed in such a way to address the misconception on climate change. So the one I'm going to show now is on the global warming, the one you have already watched. So if you see here, in the lesson 1, which is on the global warming, we have several activities. So these activities are basically designed following the 4 stages of Posner's 4 stages. Okay, so the first stage that you watch is about where does the earth get its energy. So some people say it's from the moon, some say it's from the sun, you know. So and then they have to play around. So if they click moon, then the answer will be incorrect. Then when they click sun, then the answer will be correct. So once they get the correct answer, they can move forward. So when they play around trying to get the right answer, where we get the energy from. So students are confused and have vague ideas about how Earth gets its energy. So they are not getting the clear picture. So the answer given here, it is showing it is from the sun, but some of them are having the idea it is from the moon. So while playing around trying to get the correct answer, there are several networks of knowledge that in their mind which actually trying to make sense why we are getting the energy from the sun. Okay, so move forward, they continue working on. So this is as I said, augmented reality. It is 3-dimensional view. You have to scan on the QR code and then they can actually view how the energy from the sun penetrates through the atmosphere and it reaches the earth. Okay, right. So from here, so the teacher is giving a lot of information now. So they are getting many alternative ways to make sense of the knowledge that any energy reaches the earth from the sun. In the process of it reaching the earth, there are many kinds of radiation. Not 100% all the energy that from the sun reaches completely to the earth. So there are many views here, many knowledge networks is formed at this point of time. And all these things happens because the teacher is not teaching them. You must always keep in mind, the students are doing themselves. They are operating the app themselves on the phone, on their mobile phone. So they are making sense of what's happening. So the activity is designed in such a way that it creates a network of knowledge for them to make sense. Okay, right. So that's why yeah. It's not moving. Maybe it's a internet connection. It's not moving. Maybe I'm having problem with internet. It's okay. I can share the video later with you. Then you can actually watch and get to know about it. So actually, I want to explain to you one by one, but unfortunately, I am not able to do it. I'm not sure why. What was it?
Oh, yeah. Or you have to download first, Dr. Mike.
Let me download first. I downloaded.
Yeah. Maybe it will be easier to play.
So it takes time to download. So let me explain that. So there are four lessons. If you see in the lesson 1, there are 4 activities. So the first activity is basically to create the dissatisfaction among the students. So if you remember what you have watched in the video just now, it's about students getting to know from the sun, the energy penetrates the atmosphere to reach the earth. But in the process of reaching to the earth, many radiation happen, so the energy is reflected out. So that means not 100% energy is from the sun reaches the earth. Some of it get back to the space and so on. Okay, so this is the understanding that they got at the first time. Then after that, followed with the next video. So in the next video, the next lesson, whereby, let me see whether I can download it. It would be best if I can show the thing to you. Okay, so if you see in the second and third part of the activity, it is more towards understanding. More towards understanding. We are making the knowledge intelligible. So intelligible in a way that the student did drag and drop activity. So all this they are done by themselves in the mobile app. So they drag and drop activities, and from there they know whether they are doing the right thing or the wrong thing. So they realize that some of the understanding knowledge is understandable, some is not really making sense. So this is by themselves. They are doing it by themselves. Okay. And then the final thing is you can see how you have, if you remember, there are many arrows, the energy reflection happens and all that. This is something that they come up themselves, because it is AR. They applied the knowledge, whatever they got from the activity 1, 2, 3, they come up in the activity 4. They actually design how the energy reflection happens. So that is totally application of their understanding from activity 1, 2, and 3. So there it reflects the fruitfulness. Okay, there it reflects the fruitfulness. Let me see whether I still want to show the thing. Give me a second. See whether it's downloaded. Actually, I download the video already, but I don't know what happened to it. It's okay. Let's download for a while. I can't find it now. It's okay, never mind. I will get back to you again maybe next week or what. So I will clearly tell you how the thing happens, you know, how the 4 stages of misconception is reflected in the AR Climate Change Act. I have downloaded actually, but when I open it, I cannot, it is not moving. Some technical issue. Okay, it's okay. I will come back to you again, don't worry. But just I will also share the video with you. You go through the video, then I will explain to you how the 4 stages of Posner taken place in that video. Okay, I don't want to waste the time on that section. Let's go to the PowerPoint again. Right now, I'm going to go to the today's PowerPoint. Right. Okay. Okay, can you see the strategy to remove?
Yeah.
Okay, so the AR stream is one strategy. I will go back to you again. The next strategy was POGIL. I'm not sure if you all have heard about POGIL. POGIL is a process-oriented guided inquiry learning. Okay, process-oriented guided inquiry learning. So this approach was introduced in the by group of scientists from National Science Foundation in the US in 1990, and then in 2000, after 2000 onwards, this the approach got attracted many people, particularly chemistry educators. So chemistry educators have used this approach in improving understanding as well as overcoming misconception. So the inquiry, the activity is student-centered as well as learning in group. It's not individual learning, it is student-centered, it's also learning in group. So it is a kind of inquiry that actually teacher is just a facilitator. It enables students to develop conceptual understanding. If they already have an understanding, when they engage in the POGIL approach, it also helps them to define and refine and deepen their understanding. It's not only about having conceptual understanding, it also enables them to further enhance the understanding and refine. So during the refine process, it enables them to overcome the misconception. So POGIL have already been established. It is based on the 4 stages of Posner. Okay, so how POGIL works? Basically, the objective of introducing POGIL is to develop new skills such as process thinking, learning, and problem solving, involve students in their own learning experience. Like what we did in the AR, will allow the students to engage in their own learning experience. The teacher do not do much actually. The teacher just identify the misconception and design the teaching. So in this case, it's the same. It is like the students experience their own learning. They take charge of the learning. So it also, POGIL also involves communication between students and also students and teachers. So the lesson is designed such a way that they need to communicate. I will show you how the lesson happens. So some say it improves attitude towards chemistry and science, and some say it enrich information technology. So this is from the literature. Right. Now, so in doing POGIL, actually I got this idea when I attended one of these, actually I went there for presenting my, deliver a talk on green chemistry, but I got attracted to POGIL, so I end up attending their workshop on POGIL, and after that I came back home and I tried whether it works in my context or not. So basically, they assign students into groups. Okay, the group must be small. Okay, the group must be small, and maximum in a group you only can have 4 to 5 students. Don't have larger groups like 8 or 10 students. It does not work. So smaller group students, usually 4 to 5 only for POGIL. So each group will be assigned, a member will be assigned with a role. Okay, so a manager responsible for ensuring all the members of the group will cooperate and always focus on the activity. So the duty of the manager is to make sure that all the group members must take part, be cooperative, and the activities is not going out of the focus. The activities is in focus. Spokesperson responsible for explaining answer. So they will discuss in the group. Spokesperson supposed to come and deliver whatever or share the finding or whatever the knowledge that they have attained. And then another person is recorder. Recorder take note of what's happening. It's not only documenting the results, it's also watching overall what kind of communication take place, who is communicating with who, how the knowledge sharing is happens. Okay, that's recorder. Reflector, there will be one person who will be continuously reflecting, analyzing whether the discussion is happening properly or not. What is the lacking with the discussion? How we can improve the discussion? Oh, the planning is not appropriate. So what should be the best way to, what would be the suggestion to improvise the planning? So that is the task of the group members. So you are assigned with the role. So when I did it in my context, so the students were assigned with the role, so they have the tag. So this is exactly happened when I involved in the POGIL workshop in the US when I attended the conference. So I attended the workshop. So they give tags, assign people to the roles. So we have also assigned students to the roles, and then we try to overcome students' misconception. They are unable to differentiate between weight and mass. Okay, weight and mass. So we want to teach them what is the difference between weight and mass. So how the lesson begin? The teacher posts this picture, show the picture to the student. So you can see the 3 astronauts, one standing on the earth, another one standing on the moon, another one is floating in space. So these 3 pictures we showed the student, the teacher showed the student. Then the teacher asked question, what is the difference among the 3 astronauts? What can you, what are the things that you can see in among these 3 astronauts, and what are the differences? So this is the question that teacher posed to the student. Then the students are already in the group now. So they work in the group, they identify the differences. So the manager is the group, in charge of the group to make sure everybody is working. Spokesperson will deliver the outcome of the discussion. The recorder taking note of what's happening, and there is a reflector continuously reflecting. Oh, you should think from this perspective. You should not think, oh, this is wrong. Why not you consider thinking about their different perspective? So students worked, observed and discussed the answer. Spokesperson delivered the answer. The recorder noted the answer. For the students to get to know about the teacher, the teacher did not intervene at all. It's totally about students knowing about weight and mass, and students were provided with the worksheet based on the Pojil approach. So we also designed the worksheet based on the what the Pojil people have said. So this is the first stage of activity, showing the picture, encouraging them to discuss what is the understanding they attain about mass and weight. Some group get it correctly, some group get it incorrectly. So it doesn't matter, right? Now, then they answer the worksheet. So this is the worksheet that we have given. Imagine you are positioned far from the earth in a place without gravitational force and resistance. From this place, you are asked to throw a stone. What do you think will happen to the stone? The stone will fall down. The stone will move in the same space at a consistent speed. Which is your choice of your answer and why? So this is an example of question that actually we took it from Pojil itself. So in order to answer this question, they have done the activity, the observation based on the picture. They work in the group, and this is the next level of activity. Students encouraged to think actively, communicate, and be cooperative in solving the problem. So think actively, communicate, and cooperative in solving the problem. Discuss among the group members to arrive to answers in the worksheet. They also refer to textbook, perform internet search, and make other references. Teacher monitored the activities of the discussion conducted in the group. So in getting the answer, they referred to the previous observation, what they have understood, previous their discussion looking at the picture. Then they communicated, they worked collaboratively in the group, discussed, referred to textbook, internet, and so on. Teacher did not intervene. Teacher just monitored the activity. So manager ensured all the group members participated. Spokesperson presented the finding, and at the time of presentation, whenever there is a misconception, teacher corrected the misconception. So teacher tried the best to show the misconception is incorrect. So she's right to say it in a correct way. So now you could see that the first activity we have already, when the students were doing this activity, there is already a kind of dissatisfaction. You know, they created many information, networks of knowledge. They're trying to make sense of the knowledge, which would be the correct network for the student to accept. Then they come to this stage, there is understand, they try to, whatever they got it from the first stage, they're trying to make sense in the second stage. So this is something like trying to be understand. The knowledge is more understandable, and at the same time, they're trying to believe what they have is parallel with their previous knowledge. And then our enrichment activity. So they already come to that level, enrichment activity. So what is enrichment activity? So teacher give a list of words about mass and weight. Okay, the different words that actually allow them to compare between mass and weight. So in the group, the words are placed in the envelope. In the group, they cut out the words, and then they were asked to paste in a white paper and explain to the rest of the group on why they say certain word is for mass and certain word is for appropriate for weight. So you can see the picture. The students are working in the group again with the role of manager, spokesman, and all that. They cut out the proper word and then they put it in the white paper, stick it, and then they explain to the rest of the class. So from here you can see two things: believable and also fruitfulness. Okay, so through this activity, we realized that not entirely overcome, we managed to reduce the students' misconception between mass and weight to certain level. So this is Pojil. So you might want to try out how Pojil works in your own context. Okay. Another one is so during Pojil activities, students work collaboratively and cooperatively. So that is the keyword, group work. The role assigned to the student enable them to take responsibility. So always remember, teaching happens when the student take responsibility of their work. So the in-depth exploration is when the discussion happens. Involvement in the hands-on activity made them aware of their existing misconception and also overcoming the misconception. So the key to POGIL is cooperative, collaborative, in-depth exploration. This is the key word to POGIL. So you can actually go to the website. I have actually stated the website here. So go to the website. You can actually get some more information about how POGIL works. But the problem is they are not free. The materials are not free. You have to pay, and it's all in US dollars, so it's very expensive. I did it because I attended the workshop. I got some idea and they give some materials. From there, I came back home and I designed my own POGIL. Okay, right. So I just tried it out. The next one is dual situated learning model. So POGIL is done. I hope you understand what I've said with the POGIL. So now I'm shifting you to another approach. Another approach which is called dual situated learning model. So dual situated learning model is introduced by a researcher from Taiwan. Her name is Shi Xiao something. She in 2010. So you can actually Google She 2010 dual situated learning model. You will get a lot of information from here. So in this model, there are 6 steps. Okay, 6 steps. Some studies called it as 6 phases. So it's up to you. So it's 6 steps. The first step is examining the attributes of science concept. Examining the attributes of science concept. That means as a science teacher, before you teach any concept, you will realize that what kind of attributes that concept has. That means you need to design the teaching in such a way that the students will receive the attributes. Students will understand the attribute. For example, if you talk about kinetic particle theory, right? What you want to say is matter exists in 3 phases. That is the first attribute. Then the second attribute will be arrangement of matter in the solid is closed, in the liquid is there's a space, and in the gas is they are distance apart. So this is your second attribute. The third attribute is movement of atoms or particles in the solid is restricted, in the liquid is little more, gas is more, right? So this will be your third attribute. And fourth attribute will be when you apply, you supply energy, a force to the solid, the movement is very restricted. Probably it is need more energy to change from solid to liquid. In the liquid, when you provide energy force, so the molecules or particles will move very rampantly and the bond will break or something like that. So these are the attributes of the kinetic particle theory. So when you teach students on about kinetic particle theory, you expect students to have all these attributes. You are changing, you are delivering. Your teaching actually showing the student the attributes of science concept. Okay, so that are known as attributes. The second step is probing students' misconception. So when you already know the attributes, you can probe their misconception. You can administer the diagnostic test to identify the misconception. So you can know whether they are having misconception on the arrangement of the particles, or they are having misconception on the intramolecular force or intermolecular forces, or they are having misconception on the movement of particles. So you can probe which attribute do the students have misconception. So after you probe, then you analyze the mental sets which the students lack. Because here you already have the attributes, then you already find which attributes the students having misconception on, then you analyze mental sets. That means the attributes are the mental set. They have it in the mind. So analyze the mental sets for constructing scientific review of the concept. So once you already analyze, you can design your lesson. You can design your teaching. So you can design your teaching in a various events. I will show you examples. You will design your teaching in many events. So the first event may be something which is very basic. The second event will be something which is more challenging. Okay, so these are the 6 phases. Now I will explain to you how we have done it in our context. We took She's dual situated learning model and we applied it in our context. See how we have done it. So this is we tried on acid base for lower secondary school students. That means they are 13, 14 years old. So basic understanding of acid base, right? So the mental model, the attribute here, the attribute, I want to show you the attribute. Before that, I would like to show you this. So this is the dual situated learning model that I have taken from She 2010, and you can see the 6 steps. Step 1, examine the attributes. Step 2, probe students' misconceptions. Step 3, step 4, step 5, as I said. So you can refer to this model when you want to do your work. Research later. Okay, now how actually we design our teaching. So this is for the lower secondary school student. So what are the attributes? The attributes are litmus paper only works when it is wet. If it is dry, litmus paper do not work. So that is the first attribute. Okay. The second attribute is acid and alkali can conduct electricity. Can acid and alkali conduct electricity if it is dry or if it is wet? So that is the second attribute. The third attribute is pH value of the substance, pH value of acid and base. So this is the third attribute. Okay, so these are the 3 attributes that we have decided to teach the students on acid and base. So before the lesson, we administer the questionnaire, then we want to find out what are the misconceptions the students having. Looks like with the group of students that we have done the research, all the students are having misconception on all the 3 attributes. They seems to not sure whether litmus paper, what is the function of water for the litmus paper to show result, whether it is acidic or basic, turn color. Then they are not sure whether acid and base can conduct electricity, or some say only acid can conduct, some say base can conduct, some say there is not required, water is not required for them to conduct, something like that. So these are the misconceptions. And then they also having a misconception on the pH of the acid and base, right? Weak acid and weak base and pH value and all that. So we thought that, okay, so their mental structure of these 3 attributes seems to be not in line with the scientifically accepted views. So that from the first 1, 2, 3 steps, we already know there is dissatisfaction. We have created some kind of dissatisfaction. So how we started the event? So we planned the first event, the event 1. Event 1 is conducted in 2 steps. Step 1, before demonstration, students were asked, predict what happened to the dry litmus paper after touching the washing powder and why. So this is step 1, before the demonstration. Teacher have not demonstrated yet, but she asked 1 day before the class. Okay, students, you need to got to know about litmus paper, and I'm giving you a task, predict what would happen to the dry litmus paper after touching the washing powder. Or some got the answer that, oh, the litmus paper will turn into red, some said it will turn into blue, then some said no, there would be no reaction because they are dry, so various kinds of answers. Then step 2, after demonstration. So after predicting, then the teacher demonstrated. So then the teacher asked, okay, students need to explain why the litmus paper do not change color after touching the washing powder. Students should know what they need to do to test the properties of washing powder. So some say, oh, we need to wet the litmus paper. So why do you need to wet the litmus paper? That means there is a role. Each water plays a certain role. So there is water. Water is disassociated to H positive and OH negative. Also, some kind of a role is played there. So that is the first attribute, the misconception on the first attribute. Then in event 2, before showing the video demonstration, predict which of the solution is or are corrosive, why. So before showing the video, teacher asked the students to predict which solution is corrosive. Is it acidic solution corrosive or basic solution corrosive, and why? Then the students watch the video. Then step 2, after the video demo, we got the video from YouTube. It's just a simple YouTube video. Then students should explain why both sodium hydroxide and hydrochloric acid are corrosive. So that is event 2. Why both substances are corrosive? This was followed by a demonstration of conductivity using lemon juice, toothpaste, and students need to explain the reason. So teacher showed electrical conductivity of lemon juice and why toothpaste is not conducting electricity, and they need to explain the reason. So this is the event 2. So this goes with the what you call that, stage 5 of the dual situated learning model. So this is a very simple dual situated learning. Stage 5 is the basic events. Then we continue learning in event 3. So event 3 also conducted in 2 steps. The step 1 is before demonstration, predict whether acid and base alkali can conduct electricity or not. Then they conduct the YouTube demonstration. They watch the YouTube video. Both acid and alkali can conduct electricity, and why. Okay, so event 3 is also conducted in the first 2 using 2 steps. One is they need to get their understand. They need to predict what happened prior to the lesson and get their answer. They watch the demonstration, then they discuss further after a demonstration why acid and alkaline can conduct electricity and why. And then this is also the step 5 of the dual situated learning model, which is the basic, explaining the understanding of the basic. And then going into the situational event. Going into the situational event, teacher tried to integrate. In our case, what we did, we bring the green chemistry principle inside. So we talked about several green chemistry principles when we exposed them to the inquiry activity. Then we gave them a range of household items, red cabbage juice, and pH indicator. And then we asked the students to detect which is acidic, which is basic. First, they predict first. We ask them to predict. We give them the substance, we ask them to predict. After that, they conduct the activity themselves using red cabbage and also pH indicator. Then they were asked to observe the change. What happens with the red cabbage indicator and with the pH indicator? So they ruled out the changes. So this is the situated learning event. So situated learning event is a more advanced learning, which is the step 6 of dual situated learning model. So situated learning event closely associate with the fruitfulness of Posner's 4 stages. Posner's 4 stages, right? So this reflects the fruitfulness section. Okay, do you understand what I'm saying? So I go back again. Okay, in the dual situated learning model, there are 6 steps. Okay, I didn't propose these 6 steps. The 6 steps is proposed by she who invented the model. The first step is identifying the attribute. So that is the teacher's role. As a teacher, you need to identify the attributes. So I explained to you what are the attributes. So in my case, when I want to teach the students about acid-base, so these are lower secondary school students, whereby they just need to know what are the basic substance, the properties of acid-base, that's all. So the attributes are litmus paper work when they are wet. So H2O is needed for litmus paper to function. So that is the first attribute. The second attribute is acid and base can conduct electricity. Can acid and base conduct electricity? That is the second attribute. And then the pH value of acid and base. Weak acid and weak base, and strong acid and strong base. So this is the three attributes. So as a teacher, I decided these are the three attributes that I'm going to teach to the student. The second stage is I have a questionnaire, two-tier item questionnaire. So based on these three attributes, then we probe the misconception. So when we probe the misconception, we got to know that the students are having misconception on all the three attributes. If you think your students already know the first attribute, they don't have misconception, you don't need to worry to teach, to create an event to teach. You only focus in the rest too. But in my case, the three attributes, the students are having misconception. So when I analyze, I got the understanding that the mental sets that they have, the network of knowledge with the scientific understanding, scientifically accepted knowledge is not parallel. So there are misconceptions. So I designed situated learning events. So based on the information obtained from stages 1 to 3. So how I design in dual situated events, like I explained. So dual situated event ini, there has two dual situated events. So teaching with dual situated learning event, this is a very basic one. So provide students with the opportunity to make prediction, provide explanation before and after the event, and further explain why they change their conception or retain their original conception. So here I created, I think, 4 events. So these events are actually, first I ask them to predict, then either after prediction, they need to do the hands-on activity or they watch video. Because of time limitation, we cannot do all the activities. We supply some videos, YouTube videos, for them to watch and then got the understanding. Then after that, they need to explain why their prediction is something else. From watching the video, they got the different idea or maybe same idea. So they need to reason out. Okay. After that, in step 6, but if you see the teaching in the step 5 is basic ideas. But in step 6, we engage them in inquiry. We give them a context. We engage them in solving an issue, whereby we give them a range of materials. They need to do the experiment and then they need to come up with some kind of answer. Okay, so that is an advanced level. Okay, this is an advanced level. So if you see here at the step 5, you already can see the intangible and plausible phase are taking place. You know, we are making the knowledge understandable, and at the same time, as a teacher, you are making the knowledge to be in par with their prior knowledge, or to make them understand what has to make them believe whatever you are telling, experiencing, the students experiencing at this stage is parallel with the other stage. And in the instructing, the situated learning, even the advanced stage, it's like the fruitfulness. They got to know, okay, whatever they got from the step 5, they apply in the step 6, it makes sense. So that is dual situated learning. So in our case, we have few events. So event 1, just to talk about this litmus paper. So they need to predict first, they do the demonstration, then they need to reason why their prediction is different. For event 2, we want to check on the corrosiveness of acid and base. They need to predict, watch video, then they need to explain why it is different. And further, they also did watch the demonstration of conductivity using lemon juice and toothpaste. You know, after that, in event 3, they predict whether acid and alkali can conduct electricity or not. Why? They watch the YouTube video, then they reason out why. And then in event 4, they were given a range of solution: vinegar, salt solution, baking soda. So they need to measure the pH using red cabbage juice and also a pH indicator. So they need to explain why the changes are as such. So this is all in event 1, 2, 3 is just a basic knowledge. But when come to event 5, they already have the red cabbage juice, they have the pH indicator, and we provide them with a whole range of material, household materials, varieties, coffee, tea, fruit juice, what else? Cooked food, we give them a range of material. So first they need to predict, then they need to use the juice and indicator, and they decide whether it is basic or it is acidic, and what is the acidicity level and what is the basic level. So this is the application. So fruitfulness. Okay, I think you can see it clearly, right? Now I want to show you another one. This is the one that they need to document the result. Okay, we actually got this worksheet from Stanford Education website. So this is how we gave them this worksheet to record their finding. Orange juice, tomato juice, lemon juice, so many other things also we have given to that. So after this lesson, they managed to we use the diagnostic instrument to check whether the misconception has reduced or not. Yes, it has reduced for some level, but not entirely. Okay, so that is a dual situated learning model. So I introduced POGIL, dual situated learning model. Another one is writing and knowledge construction. So here I'm going to show you two things. I also will share the paper, our paper in SERP. There are many studies done on writing to learn activity. Okay, many people have said when you use writing to learn activity, mostly for chemistry, it can actually encourage understanding. At the same, many studies have said that writing to learn activity enables students to construct new understanding. But there are very few studies have actually investigated writing to learn activity can reduce misconception. There are very few studies. So that's why we thought, why not we try to investigate whether writing to learn actually can reduce misconception. So for that purpose, we use Klein 1999 idea. He proposed that, he hypothesized that when the student writes something, when you want to write, you have a knowledge in your mind. Now you want to take the knowledge and you want to put it in a form of writing. So knowledge is generated at the point of utterance, spontaneously with planning. At this juncture, conceptual change does not occur. Instead, the writer assimilates new experiences into existing concepts. That means at the point of utterances, when I say something, you're already trying to make sense in your mind. Correct? All the students here, when I'm saying something, you are already trying to make sense. You are trying to construct something in your mind. You're trying to making sense. But Klein say, and conceptual change does not occur at that instance. But conceptual change occurs when you try to connect the networks of knowledge that you have in your mind, and you try to present that in the form of writing. So that is the first hypothesis. The second hypothesis is forward search. Forward search means the writer produces text. When you want to write, you produce text. You write, you use alphabets to write. At the same time, you will draw. You will draw graph. You will present in the form of table, or you want to put it in the form of pictures. You use many ways of presenting your idea. Correct? So that's called forward search. That means you think, it's not that the moment you think, you write. The moment you have the idea, you write. But then you digest the ideas in your mind, then you try to present it as simple as possible. You try to present it in a way that when another person look at the writing, they might be able to understand. So that in that way, you are using graphs, you are using tables, you are using pictures, you are using many modes. That's why we call it modes, multiple modes. Modes here refers to graph, diagram, picture, equation, any mode you intend to relate the knowledge to other people. The medium that you intend to relate the knowledge to other people. So in your mind, you think what will be the best, and then you take it out in the form of writing. That's called forward search. And then third hypothesis is when you have your writing and you have your graph, you will try to link the writing with the graph. Connecting. You know, you won't have a writing and then you go and draw the graph something else without connecting. You need to connect them. Okay, you have a graph, you have a writing. Writing is one mode, graph is another mode. You will try to connect. You must connect. You cannot simply put the graph there, expect, I am reading your work to expect me to understand the graph. It cannot be that way, because I will understand the graph interpret the graph in a wrong way. Might not be what you want to say. Okay, so what you need to do is you have your writing, you have your graph, you have your table, you have your picture, you need to connect them. Then only the writing makes sense. And then backward search. Backward search is planning and structuring writing to reach the goals. So in the backward search, the writer again performs planning, evaluating, revising the operation. So when you already follow, you have words, you have done your forward search, you have already do the linking. Now you work backward. You try to see whether I have done it properly or not. I replan, revise, restructure, try to make sense of the writing. Do you understand what I'm saying? Right. This is Klein's hypothesis. Klein proposes these four hypotheses. He said, if you can do the writing in this way, knowledge construction happens. And I'm saying, if you can do it this way, this is parallel with the four phases of Posner's conceptual change model. Because at the time when you want to start writing, try to think, take your whatever you have in your mind to in the form of writing, you already creating a dissatisfaction ready there. And then at that same time, when you're trying to connect, okay, I'm going to present my understanding in the form of table, or I'm going to take the understanding in the form of graph. So you are making, you are bringing the intangible inside you. So the making it easily to comprehend, making it more easy to understand. And then when you connect them together, so plausible, believable is there. Understandable and believable works together. Backward search, when you go and replan again, it makes sense. Fruitfulness is there. So this is what Klein have said in the form to write. Okay. So in our research, we didn't stop here. What we did was, we continued from here. We move forward. We say, Klein have mentioned in the form of writing to learn activity, writing, but we bring in the multi-mode representation. So what is MMR? MMR is modes, different modes. As I said, it can be equation, it can be graph, it can be writing is also a kind of mode. It can be a picture, it can be diagram, any modes. Okay. According to Disesa, she said, MMR is instrumental. If you just use words alone, without having any diagram equation, probably your understanding is not complete. But then with integrating modes, you will have a better understanding. Okay. So when you have modes, when you integrate modes, it makes the concept intangible. It makes it more easily to be understandable. Okay, so knowledge construction happens when you think about what will be the best mode to be used in your study. So you might first say, okay, I might want to use graph. After that, you feel like, oh no, graph is not so accurate. I want to use table. So in the process of thinking, actually results in knowledge construction. Do you agree with me? You know, in deciding what will be the best mode, you actually tend to construct knowledge. So this is what Gunal and all say. You know, so what I did, we have merged claims view, and we have also merged the views of multimode representation said by mostly by Gunal, Brian Hand's work and all that. We tried to address the misconception on transition method. So now I have claims work, I have work done by MMR, multimode representation. So these two advocates are two different people, two different ideas. What we did, we tried to merge. So how can I merge? How can I help students to merge easily? So what we did, we provided or we in our research, we provided the students with graphic organizer. Do you know what is graphic organizer? Graphic organizer is the students need to organize their idea in the form of graphic. So they no need to write entirely, but they can have points and then they connect their points together. So organize your understanding in a graphical, using graphical features. But in the 21st century, rather than using paper and pen kind of organizer, we thought of using digital organizer. How we can use digital organizer to allow students to organize their idea. So in organizing the idea, they use words, they use graphical features, connect them together. Okay, so what we did was we use Poplet. I'm not sure you all are aware about Poplet or not. Poplet is an application in electronic graphic organizer available at Apple Store. It is an electronic graphic organizer. So now, when the student use Poplet, that Poplet actually encourage students to think and learn, because they need to bring the ideas together in a way it makes sense. So when they're trying to bring the ideas together, both the claims for hypothesis and the suggestion put forward by what you call that, the MMR advocates, it works together. Okay, now I will show you one of the Poplet graphic that my students have created. Hold on, but I cannot put that in the what you call that, in PowerPoint slide, because it will become very messy. So I need to show in the Word file. So hold on.
Poplet is one of your publication as well, yes, Dr. Marquez?
Yes, that's in
I read that, yes.
Yeah, but that part, the publication, I think it's not very clear. You know, the diagram is not very clear. So maybe I will show you the Word.
Yeah.
Hopefully I can.
Oke, teman-teman semuanya, ini masih ada waktu 10 menit. Silakan bisa meninggalkan pertanyaan di chat ya. Silakan. Jadi minggu depan karena presentasi, jadi harus diperjelas yang belum jelas. Silakan sambil menunggu Dr. Magis mau menampilkan poplet. Can you understand when I'm talking bahasa, Dr. Magis? Suara saya terdengar enggak? Oke. Lepas aja lah ininya. Cek data untuk Windows.
Okay, can you see this? Can you see this diagram?
Yeah.
Okay, so this is the diagram prepared using Poplet app. Okay, this is the diagram prepared using Poplet app. So now you have the idea. Okay, I already mentioned the 4 hypotheses by Klein and also the mixed MMR.
Yeah.
Suggestion by Brian Hans and Gunnar. Now I'm based on that theoretical perspective. We ask the students to come up with the graphical, organize their idea using Poplet app as the graphical organizer. So they started from the segment 1. This is the most fundamental idea, the basic of idea. A complex ion is identified as an ion consisting of central metal cation bonded to a group of atom molecules or by coordinate bonds. And from this basic, they connect it with the formation of complex ion. Then they connect it with a coordinative dative covalent bond. Then further they connect it with the covalent bond formed by 2 atoms. So the properties of this complex ion is, students describe the properties of this complex ion using modes, different modes, and also in the form of writing. So the writing is the organizer that they have produced, and the MMR is the notation, the equation, the writing, and a table, structural equation, and others. So they have actually, you see, the symbols and all that. So what they did was, this thing is created by the student. So what they did was, they need to think. They need to think, how can I explain the formation of ion to another person or another student? So in order to explain that, they say, okay, at the center part, I will present the formation of ion, the complex ion. Then this complex ion is connected with the formation of ion, complex ion. Then this is connected with covalent bond. And then the covalent bond is formed by sharing of 2 atoms. And how the sharing of the atom happens, I can explain based on central metal ion transition metal Lewis acid structure. Then I can talk about ligands. So when with this what you call that graphic presentation, anyone look at this graphic presentation, they would be able to understand how formation of complex ion, the chemistry behind formation of complex ion for the transition metal happens. Okay, so in coming up, this is the product of the student, but for us to come up to this stage, the story behind it is both the Klein's 4 hypotheses and MMR, the multi-mode representation works together. Okay, so I'll share the paper. If Dr. Nurma already have the papers,
yeah.
You will understand better what I'm saying. In fact, in the writing, I have mentioned what is text box 1, what is text box 2. I've explained it very clearly. Okay, so this is one way how you can reduce misconception, and this when we merge writing hypothesis and also the MMR, the 4 the four
Hypothesis.
phases of conceptual change takes place. I think if you understand the four phases, you can actually can relate now. Okay. Now, in the PowerPoint slide, I'm done with this writing to learn activity integrated with MMR on graphic organizer. So what we did is on popular app, you might want to try out with various graphic organizer that you plan to do a study on. Okay. I have one more, which is PDEOE. That is also another approach that we have used in reducing misconception. That is a very simple approach. You can look at my PowerPoint first. Maybe next week I will go a bit more detail on that. That's a very simple approach. I think you can also read from Google. But I will go deeper on the augmented reality. How the AR, when the students use AR, with this stream education, that actually goes through the 4 stages of
CCM.
Okay, and I'll share the video with you. You can actually watch yourself. Then you can get the idea.
Yeah.
Okay, so I'm so sorry I have to rush through because I cannot take time. But if you have questions, I'm prepared to answer. You know.
Yeah. Okay. Thank you very much, Dr. Mages, with all of the things that you have already presented to go to the conceptual change model, how to reduce misconception with based on strategies and some of the model that you have already introduced. Silakan adik-adik semuanya mahasiswa, teman-teman mahasiswa ada pertanyaan. Dr. Mages, untuk minggu depan, for the next week, what kind of task that you would like to give to our students to do the presentation? A very brief presentation, so you know how they're working with these 3 meetings.
Okay, so you see, these are the master students, so I cannot something a miracle from them. So what I can what they can do is maybe they can identify the research scope, what kind of misconception they're going to work on, you know, and then if they have the instrument, they can share the instrument. If they already know what is the instrument they're going to use, and then it will be good if they can share how they're going to design. They are planning to design the instruction. So based on the 4 stages of conceptual model.
Yeah.
So that will be one thing I want to highlight here, Dr. Norma. Conceptual change model is a very old model. It is proposed in 1982. So based on conceptual change model, people have suggested many approaches like dual situated in 2010, PDOE, and it's also in the early 2000s, and also POGIL also. It's all very, I would say many people have investigated. If you really want to go for a good journal publication, if you still continue talking about POGIL, probably the question will be how your POGIL is different from POGIL people have done before. So how your dual situated is different from the dual situated which is done before. That's why when I publish this writing to learn, it looks complex. In graphic organizer, it is very complex, but these are the things that the journal looks forward. They want things like something not other people have not done. So I'm telling your students, if you want to use POGIL, no problem, but try to use POGIL in a way that nobody have done before. You know, so how can it be nobody have done before? So let's say you're using POGIL, try to use activities which are very much relevant for Indonesian context. So other people from other countries cannot do that. Only in Indonesia you can do that. Then it becomes something very new.
Yeah. Okay.
So, think about that kind of approach. You know, so if you use well situated learning model, you can use it as a theory, but try to think about something very unique that people from other part of the country, they cannot experience this. So you are suggesting this is something very new and it works. Something like
that. Okay. Yes, it's clear. Oke, jadi teman-teman semuanya nanti I would like to ask them to do in groups ya, Dr. Mages. So we will have 5 group because we have 10 students in master, but the rest of them is undergraduate, so they can learn from the master students. Jadi teman-teman mohon nanti membentuk 10 5 kelompok, jadi masing-masing 2 ya, sesuai dengan tugas Dr. Mages. Let me introduce in bahasa ya Dr. Mages. I'm sure that you understand what I mean. Ya. Jadi minggu depan mohon Anda berusaha untuk ambil satu skop miskonsepsi topik apa, ya kan gitu ya. Kemudian mencoba mengambil salah satu contoh instrumen yang dicontohkan Dr. Mages atau yang lain boleh ya. Misalnya ada 4 tier, kemarin ada 3 tier, ada 2 tier atau yang lain yang pernah Anda lakukan, bisa jadi saya yakin Anda pernah tahu. Kemudian silakan diteskan, istilahnya didiagnoskan untuk, saya yakin hampir semuanya ini adalah Bapak Ibu guru, jadi silakan berkelompok supaya mudah, yang guru-guru dipisah gitu ya, jadi supaya yang belum guru bisa bergabung. Kemudian silakan bisa rumuskan strategi yang sesuai dengan apa yang sudah kita diskusikan hari ini, dan tadi Dr. Mages sudah menyampaikan bahwa munculkan uniqueness supaya tidak sama dengan pendekatan sebelumnya yang memang itu relevan untuk pembelajaran di Indonesia. Gitu ya. Silahkan disusun dalam PowerPoint ya, dalam PowerPoint saja sehingga nanti minggu depan kita bisa presentasikan, dan singkat saja nanti masing-masing kelompok kurang lebih maksimal 15 menit, kemudian nanti kita akan berikan Dr. Mages akan berikan feedback supaya nanti Anda langsung dapat feedback dari expertnya seperti itu. Ya, nanti kalau tidak kurang jelas bisa ditanyakan di perkuliahan besok untuk PBA, kemudian untuk problematika nanti untuk pertemuan minggu ini atau nanti ditanyakan di grup. Jelas ya? Silahkan berkelompok yang supaya teman-teman blendednya nyaman, bisa bersama guru yang bisa langsung ngeteskan atau menguji cobakan instrumen diagnosanya itu. Ya, 5 kelompok jadi 2-2, per aja per. Berpasangan ya. Jelas nggih? Mas Umam jelas, Mbak Reti jelas? Oke, Mbak Dwi jelas ya? Oke, insya Allah jelas semuanya. Oke, thank you very much. Silakan ada pertanyaan untuk Dr. Mages? Yang tadi sudah dijelaskan banyak sekali. Silakan. Pertanyaan tadi.
Okay. Can you share your Telegram with me, because the video I cannot send through WhatsApp?
Okay, Telegram.
Yeah. Later you can message me
by Telegram.
Then I will.
Yeah. Yes. Okay, Dr. Mages. I have a question here from Mas Umam. Sedikit yang saya pahami model pembelajaran sejak ini. Okay, so Mas Umam try to explore those two, so conceptual change model and one of the strategies Bojil, Dr. Mages.
Okay.
They have the
I can understand that.
You can understand. Okay, you can directly to answer.
Apa yang unik dari?
Yeah.
So is she asking apa yang unik untuk manager, apa yang unik untuk spokesperson, recorder, and strategy analyst? Is that the question?
Uniknya di CCM dan pogilnya toh Mas Umam, bukan di masing-masing role itu toh. Boleh disampaikan langsung ke Dr. Mages biar mendengar suaramu yang merdu, yuk. Sampaikan aja ke Dr. Mages.
Masing-masing dari CCM.
Okay, so he asked about the uniqueness of CCM.
Terima kasih. Mungkin menggunakan bahasa Indonesia saja. Terkait ya
Singkat aja Mas Umam.
Kurang lebih apa yang saya tanyakan ini dari masing-masing dari CCM dan juga Pongkil ini dilihat dari mungkin perbedaannya itu seperti apa, yang unik seperti apa dari masing-masing model ini.
Okay. Uniqueness. He asked only but uniqueness CCM and Pojil.
Oh, uniqueness of CCM dengan Pojil.
Yeah.
So kalau nak tanya uniqueness, Pojil tu dia adalah student centered, one thing, and second thing is it's solely working based on group, kerja dalam kumpulan. Pojil tak boleh bekerja individual, it's not an individual teaching approach. Pojil is a group work. Dan ini adalah satu instructional method pedagogy. Ini adalah satu instructional method atau pedagogy. So pedagogy ini, bagaimana pedagogy ini boleh dilaksanakan? Pedagogy ini akan dilaksanakan dalam kumpulan kecil, melibatkan 4 atau 5 pelajar. Setiap pelajar akan di-assign role, seperti yang saya kata tadi. So bila pelajar melakukan tugas-tugas mengikut role yang telah diberikan kepada mereka, 4 fasa CCM, okay, 4 fasa CCM itu mereka akan melalui 4 fasa CCM. Itulah keunikan dia. So bermaksud guru perlu merancang pembelajaran atau pengajaran menggunakan Pojil, di mana pelajar akan melakukan aktiviti-aktiviti berdasarkan role-role tersebut. Semasa pelajar melakukan aktiviti mengikut role yang diberikan kepada mereka, 4 fasa CCM akan wujud di situ. Faham tak?
Ya. Jelas ya Mas Umam ya? Oke, besok bisa diskusikan kalau lanjut dengan Bu Nurma di kelas Bahasa Indonesia.
Katakan saya baca you punya thesis saudara tadi, saya baca thesis saudara. Kamu kata, okey, kamu gunakan Pojil. Pojil ini adalah berdasarkan 4 fasa CCM. Saya akan cari di mana dissatisfaction, ketidakpuasan. So, penjelasan yang diberikan mestilah jelas. Di mana agaknya ketidakpuasan boleh berlaku. Di mana agaknya intangible boleh berlaku. Atau di mana agaknya believable berlaku dalam Pojil tersebut.
Ya. Oke, jelas ya Mas Umam. Mas Umam sepertinya ada kendala koneksi internet, but he would like to maybe replay in the YouTube channel that I would like to share to the students. Okay, Dr. Mages, that's clear the explanation for Umam yang sudah bertanya di sini, Mas Umam. Jadi teman-teman semuanya kita sudah belajar hari ini. We have already learned with regarding conceptual change model ya. Jadi ada beberapa pendekatan pembelajaran tadi, metode pembelajaran yang sudah disampaikan Dr. Mages yang kita nanti bisa merujuk ke dalam conceptual change model, mulai dari kita tahu tadi ada yang stream, ya kan gitu ya, stream, kemudian Pojil, kemudian dual situated learning model, kemudian tadi ada juga yang writing. Jadi ada beberapa hal tadi, mohon bisa menjadi tambahan knowledge tersendiri untuk Anda, nanti bisa dibaca lebih lanjut di relevan literatur ya. So you will deeply understand and explore what the things to reduce the misconception in each topic. I'm sure that not all method instructional model is relevant to all topics, so we should maintain where is the best instructional model that we should introduce to the students. Oke, Dr. Mages, ada satu terakhir closing for the third meeting.
Yeah, so please go through the video that I will share with Dr. Nurma later.
Okay,
so I will take few minutes for next week to explain about the video. I'm so sorry, I am not very good in all these things, sharing. I always have problems, so I assume that I have problem exactly as I thought I had problem. So I will go through how the 4 phases is reflected in the lessons in the video. Okay?
Yeah.
Go through the video and prepare your PowerPoint slides, and hopefully we can come up with some good product at the end of the session.
Yes, that's correct. That's right. Hopefully we can have excellent works from the students. Okay, thank you very much, Dr. Marquez, for this nice and outstanding meeting in the meeting of our Visiting Professor program. Thank you very much for your sharing knowledge. And we will see next week in the same day and the same time. Have a nice day. Bye-bye. Thank you. Oke, teman-teman semuanya, terima kasih kehadirannya. Mohon nanti bisa kalau ada hal yang tidak jelas dengan tugas, bisa ditanyakan langsung ke Bu Nurma ya, lewat grup ya. Oke, selamat berkuliah selanjutnya dengan Bu Endang, dan juga teman-teman S1 sudah saya catat nih siapa yang gabung. Terima kasih banyak, selamat siang. Wassalamualaikum warahmatullahi wabarakatuh.
Bye-bye.
Bye-bye, thank you.
Waalaikumsalam warahmatullahi wabarakatuh.